Now, this pattern of fossil fuels dominating the energy consumption holds pretty much around the world, but there are some exceptions, and it's important to note them because it doesn't have to be this way if a country is endowed with other energy resources or makes other choices. France, for example, gets nearly all of its electricity, about 80% of its electricity, from nuclear energy. They've decided to go nuclear as a way of being energy independent. You can argue whether that's a good choice or a bad choice, but that's a choice France has made, and so its pattern doesn't fit these graphs I've showed. Norway, the Congo, and Brazil, rather different countries, all get a large fraction of their energy from hydroelectricity because they have big river systems that are able to supply that energy. Iceland gets a substantial fraction of its energy from geothermal sources because it's sitting on a hot spot where there's a lot of geothermal activity near the surface, volcanic activity, geyser-type activity, and it can get a lot of its energy from that. But if you take the big picture of the world as a whole, and kind of forget the distinction between coal, oil, and natural gas, which are all carbon-based fossil fuels, the answer is that the world gets about 87% of its energy from fossil fuels. The vast majority of its energy comes from fossil fuels. The energy we use in the United States and the energy that's used in the world, the vast majority is fossil fuel energy. Now, what's the climate connection? This lecture is entitled Energy and Climate. What's the connection? Well, the connection is that fossil fuel combustion and other activities associated with energy are responsible for 83% of the greenhouse gas emissions that we produce in the United States. There are other sources of greenhouse gas emissions, and they comprise about 17%. But energy production comprises 83% or produces 83% of the greenhouse gas emissions. The dominant effect there, of course, is the production of carbon dioxide as we burn the fuels, combine them with oxygen, and make carbon dioxide and water vapor. The carbon dioxide that's produced in the combustion of the fuels is the dominant effect here. But there are other energy-related effects. Natural gas is methane, CH4, a strong greenhouse gas, and anywhere in the natural gas distribution system where we have a leak, whether it's near your house or whether it's in a big pipeline, that is an energy-related production of a greenhouse gas. Refineries emit greenhouse gases. That's another energy-related emission. Abandoned coal mines emit methane. Active coal mines do too. Those are both examples of energy-related greenhouse emissions, and they're included in that 83%. Some of the sources that are in the 17% that isn't energy-related include things like methane produced from landfills, from sewage treatment plants, from agriculture. When we produce cement, we work with carbon compounds, and there's some carbon dioxide released. Cement production is a distant second to fossil fuels in causing atmospheric emissions of carbon dioxide, so cement production. And many industrial processes produce various gases, including carbon dioxide, methane, and others that are greenhouse gases, so they qualify as non-energy related greenhouse gas emissions. But again, that's only 17% of the greenhouse emissions in the United States. And by the way, these figures also include the effects of so-called carbon sinks, for instance, planting tree plantations and so on to remove carbon dioxide from the atmosphere. They're already built into this sense that 83% of the greenhouse emissions come from energy production. Now, what does all this energy buy us? What do we get for using energy at such a prolific rate? Here I'm moving a little bit out of pure science, but I'm going to stay basically quantitative. For many countries, it turns out there's a pretty direct correlation between the rate at which that country consumes energy per capita, the rate at which its citizens use energy, the amount of energy they use in any given time, like a year, and their economic well-being as measured by the gross domestic product. You could draw a straight line. You could plot a graph in which per capita energy consumption is on one axis and per capita gross national product is on another axis, and many countries would lie on a straight line. The US, Australia, South Korea, Poland, Egypt, Congo all have different amounts of energy consumption, very different, but they have different amounts of gross domestic product as well, and they scale in a proportional fashion, so they all lie on a straight line if you make a graph of per capita energy consumption. Some other countries lie well below that straight line. These are countries, and examples of them, there are many, but examples of them include Russia and Saudi Arabia. They use a fairly large amount of energy per capita. They use energy at a large rate, I should say, per capita, but they don't produce much GNP for it. And that means they lie below this average line, and they are, in some sense, energy inefficient. They aren't using their energy very efficiently if you think of energy consumption as something that's helping us to establish a high material standard of living as measured by a high gross domestic product. There are other countries, though. They tend to be some of the European countries in particular, also Japan. They consume energy at approximately half the rate that the United States does. And yet no one would call those countries, places to live that would be sort of difficult because there isn't enough energy. They're not primitive societies in any sense. They're not underdeveloped societies. They simply are using their energy more efficiently. They produce almost as much gross domestic product as the United States per capita, and yet they do so with half the energy. So how are energy and prosperity linked? Well, for a great many countries, they lie pretty much on a straight line. The more energy you consume, the more prosperous you are as measured by your gross domestic product. Let's take a look at a graph that shows all this together in one place. Here it is with Saudi Arabia, Russia, Switzerland, Japan, and then the countries, a number of countries that lie along a straight line. If I were to produce a more comprehensive graph with more countries, I would still see the same general trend. I would see a scattering of countries, some of which are more efficient so that they produce more GNP for a given amount of energy, some of which are less efficient, but they would lie on a general trend that suggests the more energy you consume, the more your gross domestic product, the higher your gross domestic product. Does that mean we all ought to be striving to consume as much energy as possible? I don't think so. I think we need to look carefully at the countries whose gross domestic product is high, but whose energy consumption is low, because those are the countries that have learned how to do things more efficiently. Now, there may be some reasons for the so-called inefficiencies in other countries. For example, the United States is a very large country. It's spread out over a big area, and not surprisingly, the fraction of our energy we spend on transportation is considerably larger than in a small European country, where some other decisions about transportation, like to have very high gasoline taxes or to have very well-developed railroad systems, may also affect the efficiency with which that country uses energy. There's also a question of whether the gross domestic product is the right measure of human well-being. And here I'm venturing about as far away from science as I'm going to get in this course, but I'm still grounded here in quantitative economics. There are a number of economists who raise the question, maybe the gross domestic product isn't quite the best thing to measure our well-being. That's because the gross domestic product includes all the goods and services that we use. For example, if there's an oil spill and we have to hire people to clean up the oil spill, the money that we generate hiring the people and the employment we generate hiring the people to clean up the oil spill, that all goes into part of the gross domestic product. And yet we would probably argue that having oil spills is not necessarily a good thing. So is there some other indicator that provides a sense of human well-being that reflects more accurately what things actually go into making our lives better? And if there is, how would energy consumption correlate with those things? Well, there are a number of forward-looking environmental economists, particularly, who are trying to formulate better indices of human well-being and to see how different societies stack up against those different measures. And one of the measures developed by the United Nations is the so-called Human Development Index. It's an alternative to the gross domestic product. And the Human Development Index has several components. One of them is the gross domestic product, a measure of the total economic goods and services in a country, a measure of its economic well-being, its material well-being as measured by money. But there are several other components in the HDI, the Human Development Index. One of them is life expectancy. Another is adult literacy. And another one is school enrollment. What happens if you make the same graph that I showed you earlier of energy consumption rate on the horizontal axis and well-being now is measured by the Human Development Index on the vertical axis? Well, if you were to make such a graph, you would find a rather different picture. You would find that countries that use very, very little energy per capita have very low human development indices. They are not in very good condition in terms of that measure of human well-being. But as you increase the amount of energy consumed up to a few kilowatts per capita, the Human Development Index, that measure of factors that includes the GDP, life expectancy, adult literacy, and school enrollment, rises rather rapidly. But at a few kilowatts, 20 or 30 energy servants per capita, the graph turns over and saturates and levels off, and further increases in the amount of energy per capita consumed don't make any great difference in the Human Development Index. So if you believe the Human Development Index is a better measure of human well-being, then you might say there's kind of a saturation effect. Does energy help us live better lives? Yes, but only up to a point. And beyond that point, increases in energy consumption don't seem to increase our sense of well-being, our human development index. Well, let me summarize this lecture. First of all, there is a large per capita energy consumption use in the world, about 20 times the human body. In North America, over 100 times one human body's worth of energy. Fossil fuels are responsible for the vast majority of that energy, and fossil fuels are also responsible for most of the greenhouse gas emissions. We get something important for that energy. We get a good material standard of living, but it looks like if we use more than 20 or 30 human bodies worth of energy, we probably don't gain additional well-being. So that's where we stand, and next we have to look at what we could do to change that mix of energies away from greenhouse emitting fossil fuels.